Hello, in this lesson, I'm going to teach you about right triangle trigonometry. Now, before we begin right triangle trigonometry proper, it can be useful to understand a few things about triangles, similarity, and proportion. So here on the screen, I have two triangles. These two triangles are similar because all of their angles are the same, which I'll show by overlapping the different angles. So we can see that their top left angle is identical. We can see that their bottom right angle is identical, and we can see that their bottom left angle is identical. So we say these two triangles are similar. Now, there is a relationship between the measures of this side and this side when we create a fraction with the lengths of these two sides that is preserved even when we move over to here. So to show that example, what I'd like to do is let's go ahead and say that this side has a length of 1. Okay, this side on the left, we'll say that side has a length of 1. And we'll say that this side has a length of 3. So we've got a length of 1 here and a length of 3. It may not be what their actual lengths are, but that doesn't really matter. So if I were to make a fraction one way or the other, I could put 1 over 3 or 3 over 1, right, to make a proportion of those sides. Now, if we use this triangle to measure these sides, right, remember this side was 1 over here. So if I measure this, we can see that the big triangle has 1, and then I can put it here. You can see that it has a side length of 2. So this one has a side length of 2. Remember, this one had a side length of 1. Okay. Also, we said this one would have a bottom base length of 3. And now let's determine what the bottom base length would be over here. So if I measure this precisely, we can see that it's at least 3. So from here to here is 3. And then I can move it to here. We can see that it's 6, right? This is another 3. So we can say the bottom of this triangle is 6. Now, if I were to make a fraction here with these two sides, we could write 1/3, for example, or we could put 3 over 1. And if I were to make a fraction here, we could get 2 over 6, which actually is equal to 1/3 because you can simplify it, or you could say 6 over 2, which is equal to 3. The point that I'm trying to make here is that when you have two similar right triangles, it means their angles are the same. And even though their sides may change, the fractions that you can get from dividing one side with the other stay the same. This is very important. That means that as long as my angles are the same, even if I shrink this down, or if I make it really enormous, even more enormous than that, if I try to make a fraction with these sides, it's always going to reduce down to 1/3. So this fraction from this side to this side will always be 1 to 3 or 1/3, as long as these angles remain the same. So this is the idea of trigonometry, which I'll meet you over on Cami. So here we are in Cami, and I have here 3 different shapes of right triangles, 3 different types. And I've highlighted their angles, as you can see, I've marked them. Now, we can say this angle is about 45 degrees. Whether it is or not currently is not the point that I'm trying to make, but let's say it's around 45 degrees. That means that if I make a fraction using this side and this side, this fraction will always be the same as long as the triangle has an angle of 45 degrees here. So even if this triangle was really large, even if it was really small, as long as I have my 45 degrees here, If I try to divide this side by this side, fraction will always be the same. It will reduce down to be the same. Likewise, if I try to make a fraction with these two sides, it will always be the same as long as I have my angle of 45 degrees, or with these sides, it will be the same. And those fractions are related to the fact that you have a 45-degree angle, because all the other triangles that are similar will also have a 45-degree angle. So they're connected to the fact that the angle is 45 degrees. When you change the angle, like over here, let's say this one is more like 30 degrees. Okay, these fractions that you would get from this triangle would be very different than the ones that you get from that triangle. But they would be identical to any other fractions, or excuse me, to any other triangle that also has 30 degrees, any other right triangle that also has 30 degrees. So if I made another right triangle that was larger or smaller than this one, but it still had 30 degrees, it was still similar, then the fractions that these sides would get would still be the same, as I showed you with my drawing earlier with this drawing. The fraction of the sides would still be the same. And that applies for each different measurement, for each different degree measure or radian measure. So we actually have a function, you can think of it almost like a database that has the ability to tell you what the fraction is for any given degree, for any position of the sides. And that is the understanding of trigonometry that you have to have in Math 2. So there's three main trigonometric functions that you're going to learn in Math 2, and those ones are called sine, cosine, and tangent. Okay, so these are your three main trigonometric functions. Or you can think of them as your three types of fractions. So each of these trigonometric functions is can be related to a different type of fraction. And the fraction is based on which sides are chosen in the triangle. So for example, if we select these two sides in this triangle, we would call this the tangent of 45 degrees if we divided this side by this side. That would be called the tangent. And so that would mean that even if the triangle was really big or if the triangle was really small, this fraction, which is called the tangent when you divide this by this, would still be the same. So the tangent of 45 degrees is the same regardless of what the sides of the angle are. In a similar way, if I chose this side and I divided this by this hypotenuse here, that would be called the sine. And if I used these sides, that would be called the cosine, depending on how you divided them. So sine, cosine, and tangent can be represented with different fractions, different ratios, depending on the position of the sides relative to the angle that you're using. So it's usually taught in this manner. We usually say sine, and it's usually abbreviated SIN. We still pronounce it sine, but we abbreviate it SIN. We say that sine of any angle is equal to the opposite side to that angle, meaning the side that is furthest away from the angle, divided by the hypotenuse of the right triangle. So that's the type of fraction that sine is. Sine is going to look where your angle is, and it's going to choose the side that is farthest away, and it's going to make a fraction with the hypotenuse. So the farthest away side we call the opposite side, the hypotenuse. Cosine is a different fraction. It doesn't use the farthest away side, it uses the closer side. Commonly taught, the word we use is adjacent, which means connecting or next to. You can think of it as the closer side, and it's going to divide that by the hypotenuse. And then tangent is abbreviated tan. So these are all abbreviations. We don't call it sin or cos or tan. We still say the full word, even though when we write it, it's abbreviated. And tangent of x, the fraction would be the farthest away side, we call the opposite side, divided by the hypotenuse. Excuse me, that's wrong. Divided by tangent of x would be the opposite side divided by the adjacent side. So these three trigonometric functions will allow us to set up equations, and because we can find opposite sides and hypotenuse when we look at triangles, and we can find angles, we can connect these three things together and use them to solve problems, which I'll show in a moment. So here I have a right triangle, and what I'd like to do is to share how we might go about building these different fractions. And so that way, you get familiar with how to use them and what they mean. So in this particular triangle, if we want to build a trigonometric function, sine, cosine, or tangent, we'll first have to select an angle to focus on. So for the purposes of this example, let's select this angle. We're going to call it x. If I wanted to build the sine of x, then I'm going to be building a fraction that uses the opposite side to x and the hypotenuse of the right triangle. So the opposite side to x is going to be the side that is farthest away from the angle x. In this case, we can see the angle x is here, and we can see it's actually touching two of the sides. And one of the sides is all the way far away from angle x, which is this side. So because it's so far away, because it's on the other side, we call this the opposite side. And that's what sine wants to use. It wants to use the opposite side. So if we say sine of x, and we start to build a fraction, we know that it's going to need the opposite side divided by the hypotenuse. So the opposite side would be 3 divided by 5, because 5 is the hypotenuse. So this would be the fraction sine of x. And we could use this to then figure out exactly what degree measure this is. That's what you would use trigonometry for, to figure out that degree measure. Okay, if we were going to build the cosine is going to use the adjacent side, which means the closer side. It's going to build a fraction with the adjacent side and the hypotenuse. So again, we choose an angle to focus on, and we choose the adjacent side to x. Adjacent side means the side that's connected to. So there's two sides that are actually connected to x, but one of them is the hypotenuse, this longer one that is kind of being pointed at by the right angle, right? That's the hypotenuse. So the adjacent side isn't talking about that. It's talking about this side. So the adjacent side would be considered to be 4. And then the hypotenuse would be 5. And so we say the cosine of x would equal 4 over 5. So we can build the sine of x, which was 3 over 5, or we can build the cosine of x, which is 4 over 5. Sine and cosine are these different fractions that you build depending on which angle you selected. So if I selected sine, I would build one type of fraction. If I selected cosine, I'd build another type of fraction using the positions of the sides that are related to sine and cosine. And if I chose tangent, so tangent of x, I'm going to build a fraction using the opposite side of x, the opposite side to x, and the adjacent side to x, but not the hypotenuse. I wouldn't use the hypotenuse. I would use the opposite and the adjacent. So that would be 3 over 4, and that would be the tangent of x, 3 divided by 4. So that's an example of building some fractions, some trigonometric fractions, trigonometric ratios using an angle. Now, these will switch if I use a different angle. So right now we've been using this angle, which is angle X. If I switch over to this angle, which we can call angle theta, that's what this symbol is, it's a theta. So think of it similar to an X, right? This symbol. It's a Greek letter. So if I switch over to this angle and I stop focusing on this one for a second, the cosine and the sine and the tangent of this angle would be different than the cosine and the sine and the tangent to this angle, because different sides are considered to be opposite and adjacent when I switch angles. Now that I switched to this side, the opposite side is going to be the 4 because angle theta is touching 3 and 5. So the opposite side would be considered 4. And the adjacent side would be considered 3 now because it's touching. 5 is still the hypotenuse because the hypotenuse is always itself. It's by definition always across from the right angle. So in this case, if I wanted to write the sine, the cosine, and the tangent of theta, we would have to consider that the opposite and the adjacent are in different spots. So sine of theta would be the opposite side. Remember, we're looking here, the opposite side divided by the hypotenuse. So we look at the opposite side to theta, which is 4, divided by the hypotenuse, which is 5. If I wanted to build the cosine of theta, we would be looking at the adjacent side. So there are 2 sides that are connected to theta. Adjacent means connected or next to. So there's 2 sides, but one of them is the hypotenuse. So we're not talking about the hypotenuse, we're talking about this guy. So this would be considered the adjacent side as long as we're focusing on theta. So we're going to build the adjacent side divided by the hypotenuse. So adjacent would be 3, and then divided by the hypotenuse would be 5. And if I wanted to build the tangent of theta, that fraction is going to use the opposite side divided by the adjacent side. So focusing on theta, the opposite side to theta is 4, the adjacent side to theta is 3, so we're looking at 4 divided by 3. So when we were focusing on theta, the opposite side was considered to be 4 because it was the farthest away side. When we were focused on x, the opposite side was considered to be 3 because that's all the way across from 3. So when you're writing a trigonometric function, it's very important that you consider what exactly you are putting inside of your trig function, whether it's theta or x, and where that is on the triangle. The position is very important. So writing one of these fractions is actually setting up the problem, and we can use this to find missing sides. We can use it to find missing angles, like how many degrees we're looking for. And it all depends on how you set up the problem. So all these problems that we have set up, the x or the theta, the variable, has all been the angle, the degree measure or the radian measure. So we have just set up actually 6 problems that are all meant to we can use those to figure out how many degrees these angles are, which I'm going to show you how to do. So coming up next, I'm going to show you how we can use these equations that we wrote to solve for missing angles, missing sides, and the process for doing that. So now I'm going to show you an example of a very basic trigonometric function problem, and one that we can use to solve and find for a missing side. So here we have a triangle. We're given just enough information to set up a trigonometric fraction, a trigonometric ratio, and we have a missing side. We don't know what this side is, and we're being asked to find it. We want to figure out what that measurement is. So what we can do is we can use a trigonometric function, set it up, and then solve it. So what we're going to do is focus ourselves on this angle. and decide which sides are x and 7 representing so that we can select the proper trigonometric function. Are we going to be using sine? Are we going to be using cosine? Or are we going to be using tangent? So since we're on angle 35, we can see that x right now is the farthest side away from 35. This means that x right now is on the opposite side to 35. 7 is the hypotenuse. So we need a trigonometric function that's going to use the opposite side and the hypotenuse. And we can look over here on the left and we can see that sine is using the opposite side and the hypotenuse. So that tells us that we're going to be using sine, not cosine and not tangent. So we can set up the sine. Remember, 35 is the angle. That's going to go in here like this. And we set this up as opposite side over hypotenuse, opposite side over hypotenuse. That's going to be x over 7 like this. So this equation is now set up and ready to be solved. We can actually figure out what x is. To do this, we want to isolate x. We want this x to be by itself. Right now, there's this 7 that's dividing the x. So to get rid of that, we're just going to multiply by 7. And this 7 and this 7, we've got to divide by 7, multiply by 7. These will cancel out. And that's going to give us 7 times sine of 35 degrees equals x. This is now solved. However, it's pretty common that when you're using trigonometry, you're going to be using a calculator. So what we can do, I have this Google calculator that I can use right here. And you can see on the Google calculator, there's a sine, a cosine, and a tangent button. And what I'm going to do is I'm going to type in this expression, 7 times the sine of 35 degrees. So I'm going to come over here and I'm going to type 7 times the sine of 35. Now, the Google calculator does not have a degree symbol, but you can see right here, there's a toggle between radians and degrees. And if you click it, either radians will be emphasized and degrees will be grayed out, or degrees will be emphasized and radians will be grayed out. Since we're working with degrees, we want to make sure degrees is selected and that radians is grayed out. So what this is saying now is 7 times sine of 35 degrees. And we just press equals here and we get 4.015. Now, it's common to round this. Usually the rounding directions will be given to you by your teacher or by whoever's asking you to solve for that side. A good rule of thumb is to round to 2 significant decimal places, just in case that there's no rounding directions. So because we don't have any rounding directions right now, we're going to go ahead and round to 2 decimal places, which will be 4.02. So we can say 4.02 is about what x equals. So x is about 4.02. And that is how we can solve for a missing side in this scenario. Here I have a slightly different example where we can solve for a missing side. In this case, we're solving for the hypotenuse. Now, the solving process for this one is slightly different, but the setup is the same. So we are going to focus on the angle that we are given, which is 40 degrees. And then we're going to determine which of the trigonometric functions we're going to use by looking at the triangle and determining which sides do we have. Do we have the opposite side? Are we expected to use the hypotenuse or the adjacent side? So if we look here, we're going to use this 10, and the 10 is across from the 40, so this would be the opposite side. And we have this x here, which is the hypotenuse. So we're going to be using the opposite side and the hypotenuse. We look over here along the left-hand side, we can see opposite side and hypotenuse, that's sine. So we can write sine of 40 degrees. Again, putting the degrees, you put the angle in the argument of the sine, you put it in the parentheses there. So we say sine of 40 degrees equals the opposite side, that would be 10, divided by the hypotenuse, which would be x. In this situation, we have just set up the problem. It's ready to be solved. However, we see that unlike the previous example, x is now in the denominator. So since x is in the denominator, we need to get it out of there because we can't solve for x if x is in the denominator. So to get x out, what we're going to have to do is actually cancel it out of there. Right now, we're having 10 divided by x. Since we're dividing by x, the way we cancel x in the denominator is multiplying by x. And we'll have to multiply both sides. So here, this multiplication by x is going to cancel this division by x. So these will go away. And we have x times sine of 40 degrees equals 10. So now that x is no longer in the denominator, our goal is now to isolate the x. We want x to be by itself on one side of the equal sign. So we need to get rid of everything that's on the same side of the equal sign as the x, which right now is this sine of 40 degrees. And we can see that the sine of 40 degrees is being multiplied. So what we're going to do is we're going to divide both sides by the sine of 40 degrees. We're going to divide here and we're going to divide there by the sine of 40. And what happens now, multiply by the sine of 40 and divide by the sine of 40 cancel out. And we have x equal to 10 divided by the sine of 40, which means our x is now isolated. Now, notice that when x was in the denominator, the solving was a little different than when x was in the numerator. It's important to keep that in mind and not just try to cancel the 10 here. Instead, we need to get x out of the denominator by multiplying by x, canceling it out, and then isolating x. So here we have the solved problem, x equals 10 divided by the sine of 40. We can put this into a calculator. We can put 10 divided by the sine of 40 degrees. Make sure it's set to degrees and press equals. And we get 15.55723, etc. Because there was no rounding directions, I'm just going to round it to the nearest hundredth place, which means this is going to be 15.56. So we can say the hypotenuse was 15.56. Here I have another example because I thought it might be helpful to see an example that used a different trigonometric function. So in this example, we have here an angle that's up here, 70 degrees. And so we're going to focus on this angle and we're going to look at our triangle and see which sides are we going to be using. So we definitely have to use this side. And if our degrees is up here, then this side being all the way across onto the other side of the triangle would mean that this would be the opposite side. Then 5 would be the adjacent side because the hypotenuse is still over here. By the way, it doesn't matter if the triangle is flipped over or it's reflected to the other side, if it's shaped like this, or if it's shaped like this, or if it's shaped like this. Because as long as you understand that we're talking about focusing on an angle and then thinking about the sides that are farthest away or the sides that are closer or the hypotenuse, those sides it doesn't matter how the triangle is facing. It just matters the position of the sides compared to the angle. So in this case, we are going to be using the opposite side and the adjacent side. So let's go ahead and look which trigonometric function uses opposite side and adjacent side. And that would be this one. So that would be tangent. So we say tangent of 70 degrees equals the opposite side divided by the adjacent side. That would be x divided by 5. To solve this, we're trying to get x by itself. X is in the numerator already, so all we need to do is cancel this 5, which we can do by multiplying both sides by 5. That's going to give us 5 times tangent of 70 equals x. So let's come to our calculator. We say 5 times tangent of 70 degrees. Make sure it's set to degrees. Press equal. We get 13.73. We're going to round to the nearest hundredth because we don't have rounding directions. So that's going to become 13.74. So that's an example of using tangent instead of using sine. Using cosine, again, would be slightly different. But the overall process is the same. You set up your fraction, you set up your trig, and then you solve as appropriate. In this example, we have a right triangle that is oriented in a slightly different way, and we're going to be using a different trigonometric function. So let's, once again, focus on the angle that we have in order to set up our function. So we're focusing on angle x. And let's look at the sides that we are given and see which sides they are. So angle x is here. That means it's touching this side and it's touching this side, which means this side over here, this one, would be considered the opposite side. It's currently blank, so we know we're not going to use it. The 8 is the adjacent side. The 17 is the hypotenuse. Since the right angle is here, that would make 17 the hypotenuse. So we have an adjacent side and we have a hypotenuse. So we can set up the equation to be cosine of x, because cosine is the one that uses adjacent side and hypotenuse. Cosine of x equals adjacent divided by hypotenuse, 8 over 17. Now, in order to figure out the degree measure, we have to solve for x. Now, solving for x when it's an angle inside of a trig function can be a little different than what we're used to, because we need to cancel that trig function, leaving behind the x. Now, it's important to note that this interaction right here, this is not a multiplication. Cosine is not multiplying x. That's not what's happening. This is more similar to when you have f of x, right? And we know f doesn't multiply x. It's just saying that it's a function with x as the input. So how do we cancel cosine? Or if we had a different problem, how would we cancel sine, or how would we cancel tangent and leave behind the x? What we need is, we need an inverse function that can cancel cosine, similar to how addition cancels subtraction or how division cancels multiplication. We need something that can cancel cosine. And so let me introduce you to the inverse trig functions. So we call them arc sine, arc cosine, and arc tangent. And these are the abbreviations here: arc sine, arc cosine, and arc tangent. And we can use arc sine, arc cosine, and arc tangent to cancel sine, cosine, and tangent. That's their purpose. They are inverse functions designed to cancel those trigonometric functions. Now, sometimes they're written like this. Sometimes they're written like this. And sometimes they're written in an even different way, like this. But regardless of how they're written, these mean the same thing. So if you write arcsine like this, or if you write arcsine like this, or if you write it like this, those all mean arcsine, and these will all cancel sine. Likewise, these will all cancel cosine, and these will all cancel tangent. So in order to cancel this cosine, we're just going to need arc cosine. So let's go ahead and apply arc cosine to both sides. So we apply arc cosine over here. We're going to apply arc cosine over here. So the arc cosine will cancel the cosine and leave behind just the x. And on the right-hand side, we'll have arc cosine of 8/17. Okay. And so we would use these inverse functions as long as we're trying to get at the angle in there, if that's what we're trying to solve for, is that angle. So we end up solving it. We get x equals arc cosine of 8/17. We can plug this into a calculator using, again, our Google calculator. And the way that we can find arc cosine on the calculator, most calculators will have a button that says either it'll say inverse, or it'll say second, or it'll say shift, or something like that. And when you click that button, it turns the sine into the arc sine button, it turns the cosine button into the arc cosine button, and it turns the tangent button into the arc tangent button. So now that I've clicked inverse, you can see it's selected. If I now click sine, it's going to give me arc sine. See? And notice how on the button it says sine to the power of -1. That's what it looks like anyway. And what this is really saying is inverse sine. So if I click this, in the calculator, it says arc sine. So what do we need? Oops. We need arc cosine of 8/17. So we're going to press inverse cosine. That's going to give us arc cosine. And we have 8/17, which means 8 divided by 17. And again, we're working with degrees, so make sure it's set to degrees. And we press equals, and we get 61.92. We're going to round to the nearest hundredth since we don't have any rounding directions. And that's going to give us 61.93 degrees. So x equals 61.93 degrees. So these are the three most basic ways to use trigonometric functions. I think we'll do one more example and then I'll let you go. Okay, in this example, we are given all three sides and the missing angle. And once again, our right triangle is oriented slightly differently. This time our right angle is here. So because our right angle is here, we already know this is the hypotenuse. Now, if we were going to solve for x, because we have access to all three sides, we really can choose whichever one that we want. So since we haven't used tangent a whole lot, let's go ahead and use tangent. So we're going to need the opposite side and the adjacent side to x, not the hypotenuse. So we're not going to use 13. So the opposite side to x would mean the side that is furthest away from x. Right now, our angle of x is touching this side and it's touching this side, but it's not touching this side. So 12 would be considered the opposite side. So we're going to say tangent of x equals 12 over 12 was the opposite side, and the adjacent side would be 5 because 13 is considered the hypotenuse. So the adjacent side would be 5. We put a 5 here. To solve for x, since x is the angle, we need to cancel the tangent, which means we're going to need to use arctangent. So let's go ahead and take arctangent and apply it to both sides. So we're going to call this arctangent here. We're going to apply arctangent over here. And arctangent and tangent will cancel out, and that will give us that x equals 12 over 5. Excuse me, arctangent of 12 over 5. So now this is solved. We can plug in this into the calculator. Arctangent, 12/5. We get 67.38. Since we don't have rounding directions, my rule of thumb is to round to the nearest hundredth, which is just 67.38. I guess it's an estimate. And so that's how we use trigonometry, even when we have all of our sides given to us. Okay, so now what I'd like to do is I'd like to present you with an example of a real world situation using real life objects that might have trigonometric ideas built in. So let's say that you're going to lean a ladder up against a wall. So here is the ground. Let's say this is the wall. This is a cross section of the wall. You're going to lean a ladder up against it like this. Okay, notice that this is a right triangle in here. Right? We have a right triangle right here. Very important. In trigonometry, since trigonometry uses the hypotenuse, trigonometry at this level in Math 2 is used on right triangles. So let's say that we have a ladder that we're leaning up against the wall. Now let's say that we know that the length of the ladder is 10 feet. So we know it's a 10-foot ladder. And we're trying to reach a point that, let's say, is 6 feet up the wall. We might ask, what is the angle that the ladder makes with the wall? Or, excuse me, what is the angle that the ladder makes with the ground? So in this case, in order to solve this, we can see that we're going to be focusing on this angle, and we actually have our triangle right here. So you can almost treat it with even without the word problem context now. So we have our angle here, which would be x. And we have our 6 foot, which is far away from our x. This would be considered the opposite side. And we have 10 feet, which is considered the hypotenuse. So opposite and hypotenuse means we're going to use sine. So we say sine of x equals 6/10. So we're trying to solve for x, which means we need to get rid of sine. So we're going to use arc sine. So we apply arc sine to both sides. That's going to cancel out sine, and we're going to have x equals the arc sine of 6/10, which we can put in a calculator. Arc sine, right? Press inverse and then sine. 6/10. 6 divided by 10. 6/10 equals 36.869. We're going to round to the nearest hundredth. We get 36.87. And this is an approximation. So this would be an example of a very basic trigonometric word problem, something that is not too complicated, doesn't require too many steps. So to summarize our lesson on trigonometric functions, the trigonometric functions are fractions that are based on triangles being similar, so that if we have a degree measure or an angle measure, that we know that those fractions will always be the same. So that means if I have, for example, 30 degrees or 45 degrees, as long as I stick with that same amount of degrees, as long as that angle stays the same, I know what that fraction will be. It will always be the same. So that allows us to write fractions for triangles and use that to find different sides and angles regardless of the size of the triangle. So in order to use the trigonometric functions, we must be familiar with the three functions, their names: sine, cosine, and tangent. We must be familiar with how they're built, how the fractions are built, the ratios. So we know sine of x is going to be the fraction made with the hypotenuse and the opposite side. It will be opposite side divided by hypotenuse. Cosine of x is the adjacent side divided by the hypotenuse. And tangent of x is the opposite side divided by the adjacent side. Tangent of x does not use the hypotenuse. It's important to understand that the opposite side means the side that is farthest away from the angle that you are focusing on, and that the adjacent side means the closer side that is not the hypotenuse. Because angles will usually have, or because the angles will always have the hypotenuse as one side that's connected and then another side, the adjacent side is always the other side, not the hypotenuse. So we focus on an angle. You're going to then determine which sides you're using. You're going to build your ratio. You're going to write it, and then you're going to solve. And solving is going to be different depending on if you're solving inside the trigonometric function, trying to solve for an angle measure, or it's going to be also different if you're going to be solving for sides. And it is slightly different if the variable is in the numerator versus if it's in the denominator. So that is the very basics of trigonometry. Good luck as you work on your independent practice.